started on Rust-004. I guess Rust-003 we had the issues in the videos, and I guess I did that complete stream without the video, but that's all right. All I covered was the structure that was part or the chapter number 4, and we may come to that at any point of time later. uh, Let me also check other things. 1 second. Just my YouTube video. All right, so what we can do is first check whether video is live or not. All right, so video seems to be live. Only thing is quality is auto. Quality seems to be bad right now. Hello. Okay, so voice is fine. Alright, so let's continue on chapter number 6. So that's on enums. Right, so every language has enums in some or the other ways. So does Rest. So it says that these are, so we have to say define enums as v4 and v6. I'm not sure by default if this v4 is equals to 0 or v4 equals to 1. Do we have anything like that in this one? Let's check that. So this enum is now a custom data type. So I guess this is me who is looking into this one, so I'll just close this. So I have v4 and v6. This is an enum for this particular enum, so this is another custom data type. So if we want to access that, so we have to use the scope resolution operator or the namespace under its identifier. Okay, and again we discussed that inside the enums we call these values as the variance. So we can also loop through this one, and that takes in, oh sorry, I was thinking that's a for loop. So this is a function route which takes it as an enum, and then based on enum maybe it takes some operations. Yeah, and we can call this using this scope resolution operator. Again, inside struct we can define, we can declare one kind that is a type of this derived data type, and then again we can just initialize this one. So this is straightforward. I don't think there's you want to run this, I don't think it will display anything because nothing is printed to the console. All right, so that's okay. There is another thing. It seems that it's annotated it with the data type, more concise. Rather than an enum inside a struct, we can put data directly into each enum variant. This is new definition. It says that both v and v6 will have associated string values. Okay, IP header v4 is this one, and let loop back IP header is something this one, colon 1. Extra struct. Here it's also easier to see another detail of how enum work. The name of each enum variant that we define also become a function that constructs an instance of the enum. All right. is a function call that takes a string argument and return an instance of IP header type. Oh, all right. So this is of type IP header. So this is something new. Therefore, another advantage to using an enum rather than a struct, each variant can have different types and amounts of associated data. So version 4 type IP address will always have a 4 numeric components that will have value between 0. If you want to store v4 address as our v8 value but still v6 as a minus string, we wouldn't be able to do with a struct. Enums handle this case with ease. Alright, so this is interesting. Let's copy this and open our last project. That was this one, I guess. So here I'll create a new project for this one. CD project, and another is cargo enum. I'll write enums, and we have the enum project, and here I'll just copy paste this, and I can just print this for now. So we can have value as home. Okay, so this is not, I guess we can do something like this, and we have to pass that debug. What is that we did in struct, I guess, for debugging this one. We were doing that. Where did we do that? Not sure where. Anyways, so we have to add this to this one, and then we will be able to print this. What is that? Derive hash derive debug. So we need to remember this hash derive debug, right? So once hash derive debug works, then we will be able to print these values. As we saw that if we pass this directly, then the ownership will change to println, whatever the scope is. So Rust doesn't allow that. So cargo run cd enums cargo run. Yeah, all right. So it printed the enum along with whatever was assigned. We can also embed structure inside this instead of just these tuple values. These are tuples, right? So instead of that, we can also have a struct. So for instance, so we can also have wide variety types of embed in its variant. All right, so this is just a quit. You can have a move which can take x and y kind of embedded structure. You can also have a write which can take some value. You can just have a tuple similar to one variant. So there is some option in enums as well. So let's look into that. This already we saw that if you want to have associated method with not associated method but the methods with the structure, then you have to have this IMPL, and based on that you would be able to create methods in the struct. So this option, I guess, is similar to the one we also see in the Java in Java 8. So where you can have an optional argument so that may return a null value or something else. Standard library, the option types encode the very common scenario in which value could be something or it could be nothing. Yeah, same thing. So I will also open medium to the story. Write the story. Rust-004. That's Enums, maybe 5. So design is often thought of in terms of which feature you include, but the feature you exclude are important. Rust doesn't have the null feature. That may null is the value that means there is no value in language with null. So Rust doesn't has the null. Represent null references the $1 billion mistake. Hoare, the inventor of null, has this to say. I call it my $1 billion mistake. At that time, I was designing the first comprehensive type system for reference in an object-oriented language. My goal was to ensure that all use of references should be absolutely safe, with checking performed automatically by the compiler. But I couldn't resist the temptation to put in a null reference, simply because it was so easy to implement. This has led to innumerable errors, vulnerabilities, system crashes, which have probably caused $1 billion of pain and damage in the last 40 years. It's a very good mistake. Sorry. Very good statement by Tony Hoare. The problem with null value is that if you try to use a null value as a not null value, you'll get an error of some kind, or you will even get a runtime errors and you will crash everything. Is a pervasive. It's extremely easy to make this kind of. However, the concept that null is trying to express is still a useful one. A null is a value that is currently invalid or absent for some reason. The problem isn't really with the concept but with the particular. As such, Rust does not have nulls, but it does have an enum that can encode the concept of value being present or absent. This enum is option T and it's defined by the standard library. So I guess here you also have the what do you call it? Templates. The option T enum is useful, but it's even included in the prelude. You don't need to bring it into scope explicitly. Its variants are also included in the prelude. You can use some and none directly without the option prefix. The option T enum is still just a regular enum, and some T and none are still variants of the type none. The T syntax feature of Rust we haven't talked about yet. It's a generic type parameter and it will cover generics in more detail. Okay, so it's C++, Java, now even in Golang we have a generic, so that means that it can have any type, and based on type you are going to have some do depending on what T is. So this sum can take any type. Some a string option, so absent number equals to none. Type of number is option, so that's also important. Option T instead of null. You have this option T. The type of sum number is option I32. The type of sum string is option $str, which is of different type. Rust can infer these type because we have specified a value inside some variant. Alright, for absent number, Rust requires to encode the overall option type. The compiler can't infer the type that corresponding will have whole. Yeah, so because it also has 5, so it knows what type it is, but here it doesn't know what type is, so we will just put a none. But I'm not sure how directly outside this it's able to access this. Maybe, I don't know. When we have a sum value, we know that the value is present and the value is held within the sum. When we have none value in some sense, it means the same thing as null. We don't have a valid value. Yeah, in short, because so how this none is better than null? In short, because t are different types, the compiler won't let us use an option value as if it were definitely a var. For example, this code won't compile because it's trying to add an i8 to an option i8. What does that mean? Oh, okay. So it's a simple i8, and it won't allow to add it to I because those two types are different. In fact, this error message means that Rust doesn't understand how to add an i8 and an option i because they are different types. When we have values of a type like i8 in Rust, the compiler will ensure that we always have a valid value. We can proceed confidently without having to check for null before using that. Only when we have an option i18, then we need to get the sum value from this one, and then only so that particular thing can either be none or it can have some value t before you can perform t operation. So how do you convert this t? Option t enum has a large number of methods that are useful in a variety. You can check them out and it's becoming familiar. Okay, so it says that you have to read the documentation, and based on that, so option t sum x dot is sum. Okay, you can also check whether it is holding some value or not. So if you define a num in this one, then its sum will be false. Okay. Okay, so there are multiple things. So we need to like dig more detail into when we are using options, see some. So let's try to find those out. Rust option use case example. We already have a Rust by example. So sometimes desirable to catch the failure of some part of program instead of calling panic. This can be accomplished using the option enum. So I guess after we are done with the book, we can also go by Rust by example so that we have more intuitive understanding into Rust and how different concepts and libraries are being used. So here what it says that to indicate failure. Okay, so there is a divide by zero expression most importantly, I guess. So let's start from this one. So try division 4 and 2. Try division. So match dividend, check division. So it will go here. If divisor is 0, so you return a none. Result is wrapped in some variant. So if you get the value sum, so you can just print dividend, divisor, and quotient. Alright, that's from the match clause. Binding none to a variable needs to be annotated. Okay, this can also be like this one, optional float. Alright, so this is match based on that, either none either sum. You will just print it. This is also expression, so if you want to assign it, then you can also do that. If we have to do a return of this one, so you can just assign to it, and in the last line you can just return that. Alright, so that makes sense. The match control flow construct. So let's go into the last. So this is enums are done. The match control flow construct. Rust has an extremely powerful control flows construct called match. Yeah, we already seen that match, so maybe we will see this match in more detail against a series of pattern, then execute. So we already saw that match. Inside that we will be having its arms, and based on that, what is the resultant value that will be matched against that particular type. Think of a match expression as being like a coin sorting machine. Coins slide down a track with, and it falls to the first one, and then it fits into. In the same way, values go through each pattern and match, and at the first pattern fits, falls into associated globe block to be used during execution. All right. So here, so match based on the coin. So whatever, so it will return. So it will either return 1 if it's penny, it's a nickel. Okay, so this can be used to get the values of these enums. So that's also nice. So we already know that, so I'm not going to go deeper into these enums. So value in cents, it's also match coin in 10 penny. Yeah, if this is correct, then you can print this and then return one. Oh, so remember that time we were trying to do that, so we could have used this. First day, right, we were trying to print the values, so we could have just print the values in this curly braces and return this particular one, because last one is the statement. So this good. So expression will bind to the values. Right. Another useful feature of match arms is that they can bind to the parts of the value that match them. And this is how we extract values out of enum variants. Let's change one of our enum variant to hold data inside it. Okay, we can also from 1993 to the United States minted quarters with different design for each of the 50 state on one side. No other coins got state designs, so only quarters have this extra value. We can add this information to our enum by changing the quarter variant to include a US state. So US state, that's enum. Okay, quarter will all the US state. Let's imagine that a friend is trying to collect all 50 state quarters. While we sort our loose chain by coin type, we also call out the name of the state associated with each quarter. So if it's one our friend doesn't have, they can add it to their collection. Okay, match coin and coin quarter state, and it returns the value quarter state. But where we would get this quarter value? If we were to call value in cents coin or quarter, coin would be coin quarter. Okay, so here we have to call this coin quarter, and coin would be when we compare that value with the match arms. Okay, so we create a coin along with the scope resolution operator quarter, and we can hold some value inside this one. Again, we have created an enum for, so in order to create an enum for that type, we will use the scope resolution operator to use that enum. So that's all right. So again, we can also use matching with options. In the previous section, we wanted to get the inner T value out of the sum case when using option D. We can also handle option T using match as we did with the coin enum. Instead of comparing coins, we will compare the variant of option T, but the way that the match expression works remains the same. All right. Let's say we want to rewrite a function that takes an option I32 and there is a value inside, add 1 to that value. If there isn't a value inside, the function should return the none value and not attempt to perform any operation. This function is very easy to write thanks to match, and we will look like 6 to 5. None sum of I plus 1. Matches are exhaustive. Sum of I plus 1. Catch all patterns and the placeholders. Alright, it seems that mostly match we have covered. So a dice roll, add fancy hat. So we can also execute certain functions on here. Okay, so we can go ahead and check chapter number 18 to read more about these pattern matchings. What is that underscore? So go to instead of the variable name other. You must roll again. We don't need to use the value in that case, so we can, okay. So this is kind of a default thing. If you do not roll 3 and 7, you have to just read. Okay, so underscore means a default. So it's a default in case default arm of this match statement. All right, nothing much here because we already done this match quite a bit. Only new thing we have to practice is options. So maybe we can delve more into options and practice these when we are going to use the options or not. All right, so let's go to the last concise control flow with if let. As we already seen that some. All right. The if let syntax lets you combine if and let into less verbose way to handle values that match one pattern while ignoring the rest. So this has only one pattern. So where's the if? Okay. So if let equals to config max. Oh, that's complete opposite. All right. So it's kind of opposite to how we assign this value. So match, it says that whatever value we have passed for this particular match expression, if you match any of these arms, so here for anything else it returns and it doesn't match anything. So what it says that remember this syntax. If the value is sum, we print out the value in some variant by binding the value to the variable max. If we don't want to do anything to satisfy the max, we have to add underscore after proceeding just one variant, which is annoying boilerplate code to add, right? Because we only want, so you can easily do an if clause. If sum max equals to config max, that's it. It's a good thing. We could write this shorter way, if let. So this is a new syntax, if let. Again, slightly syntactical, but it's all right. So whenever you have a single arm in match clause, you should use if let. That's all right. The syntax if let takes a pattern and an expression separated by an equal sign. It works the same way as match, where the expression is given to the match and the pattern is its first arm. In this case, the pattern is sum and the max points to the value inside. So we can then use max in the body of if let block in the same way as we use max in corresponding match arm. The code in the if let block isn't run if the value doesn't match the pattern. All right, so right, this is cleaner than this one. Syntax sugar for mash that runs the code when the value matches one patterns. Yeah, same thing. We can include an else also with an if let. All right, so again, if you want to have two uh, things, then you can again have an if let. But I'm not sure how when you will. So why can't I directly if state equals to 0 coin? Yeah, that's slightly confusing, but for now remember that anytime you are creating a match with which only has a single arm and maybe has a default value which doesn't do anything, it's better to do that with if let. And again, even if there are two um, two arms, another default is doing something, you can use this if let these things, right? If let and else clause. So that's it for if let, I guess. Yeah, I guess by the time if I was doing Golang or anybody else was doing Golang, I guess we would have kind of done covered most of the things because code does not have so many um, language level features. I guess another thing that I am more interested is still there is no concurrency. All right, so we have this concurrency. So maybe this will be interesting. So maybe tomorrow we can first look into concurrency. Patterns and matching I will leave for now. And another one will be this object oriented features of REST. Okay, so you have these visibilities, IMPair. Okay, so you can also have the functions public, and then see what fields have. Maybe by default those are private because just try to safeguard everything. Yeah, so this is fine. So also we have the vectors here. I guess that's the vector. We will see that tomorrow or day after tomorrow. Pointers we will see it later. Cargo function. We are also interested in functional language features. Building a command line program, that's also nice. Yeah, but we can look into this one later. Error handling, we haven't seen any errors till now. How does a function return an error or exceptions? Yeah, we saw we can return a result, either OK or ERR that we saw. And then yeah, so I'm more interested in looking into concurrency first. So probably tomorrow we will jump into chapter number 16. So there is also message passing between the threads. So it also has the channels. That's interesting. All right, guys. So I guess this is it for today. And tomorrow I'm pretty sure I will be first covering concurrency, thread features. There is also communication between the threads. I guess that will make it a bit interesting because right now it's too much too much to too much data to kind of digest. All right, bye bye.